All right, so in this video, we're going to look at another container type known as dictionaries. All right, so previously we've looked at lists, we've looked at sets, and those are containers that really just, stored single values, right? So we might have a list of, the integers 1, 2, 3, and it could have been mixed types. We saw that. And sets were kind of the same way, except sets just required the elements that were within that set to be unique. So if you had provided duplicates when you defined the set, it would have removed any of those duplicate entries. All right, we're going to look today at dictionaries, which are a little bit of a departure from what we've seen with lists and sets. In particular, right, so I'm going to make a dictionary. So I'm going to say this is going to be my, let's just say customers. All right, and dictionaries, very similar to a set, are going to be defined with curly braces. But instead of it being just single values like a 1, 2, 3, let's actually demonstrate this. So if I were to define this here, the type is going to be the type of customers, I'm sorry. All right, we see that that's a set. All right. Now, when we're doing a dictionary, so I'll leave this. Let me actually kernel restart clear all outputs. Let's call this customers set. All right. So now if I do this, and what I'm going to do now is I'm going to make a dictionary of customers. All right. All right. Now a dictionary, where it's going to differ is instead of just having 1, 2, and 3, for each element, it has another value. So what we're going to see, like, let's maybe think of our customer dict is going to store the names of our customers, and this integer is maybe representing a customer number in our database. So customer number 1, that refers to Alice. Customer 2 refers to Bob. And then customer 3 maybe refers to Carl. All right, so the only difference is for each one of those elements, I've now got a colon, and then I've got an additional value. Okay, if I run this, let's see, I've made a mistake. I didn't close off with my single quote there. And now if I look at this type, and I'm going to do that with our customers dict. Now this is a dictionary. All right. Now, so here's the key thing. Dictionaries are key value pairs. All right, so that's the key thing with the dictionary. So like right here, I'm highlighting that 1 colon Alice. So 1 is the key, Alice is the value. So we have key value pairs. It allows us to map between two essentially representations for an entity. So Alice can be referred to by her name Alice or the key 1. Okay, so it is a mapping between one variable or one value and another value. Okay, and I would encourage you, right? So one thing that I'm going to try to enforce more and more as we start building more complex code, let's do things that will help us, maintain readability. When I define dictionaries, this is kind of how I would do that. Instead of just putting it all on one line like this, right? What I might do is right here after that 1, or right before the 1, I should say, I'm going to hit enter. Then I'm going to do the same thing there. I'm just deleting these spaces before each one of those. And then I'm going to end it with a comma. And now I've got my dictionary built across multiple rows. All right, now there's 2 things right here that we just introduced. They seem super, super subtle, right? So first off, notice that that Jupyter was putting this white space here. So in Python, white space is significant. And it's used to indicate relationships. Okay, so we'll end up seeing a lot more of this when we get to the for loop, but the fact that it put the space here, it's just trying to visually show us that, hey, this line is following from that brace. So you started a dictionary here, and all of these nested entries under belong to that dictionary up until you get to that lower brace here. All right. I'm using the comma to separate key value pairs. And a reason that I like this a lot better is, let's suppose that, maybe customer number 2, maybe Bob is no longer with us. Well, now we can just go back and simply highlight Bob right out, and our dictionary is going to remain valid. Whereas in that previous form where it was all out, let me just go back. Remember what that looked like. if we needed to take Bob out, right, well, we can't comment it, so we actually have to just go remove it. But in our new representation, let me get that back the way we had it just then. Right, if we wanted to maybe have Bob out of that dictionary, we can just comment it out, but it leaves a record in there. Right, so it just makes things easier to kind of comment certain situations out. All right, so this is a dictionary. All right, so if we were to print this out, we've got keys and values. All right, now let's look at this. So we've got this dictionary object. If I do a dot and hit tab, all right, here's the methods that are available. Notice that we have a keys method. All right, so if I were to do this, do a dot keys, open and close parentheses, that gives me back those keys. Now here's a key, very important thing. Notice the type of this, right? This looks like a list. It is not a list, right? If I were to do the type of this, okay, these are dict keys. We could iterate over them like a list, but they behave slightly different than a list, okay? Like for example, if I were to store these, here's my keys. What if I were to store these as like, my keys? Okay. Well, we look at that, it looks list-like, right? What if we ignored that and we tried to do like an append to that, thinking it's a list? You're not going to be able to do that, right? Because your type is not a list, it's a dict key. So again, kind of going back to what I've said in many other videos, the type defines what you can do to an object. So this is not a list, this is dict keys. All right, we can convert this to a list if we wanted to. We could actually just wrap it in list like we kind of did when we were looking at sets, and I can get a list of those keys back, and now I could do an append to it. Right? But otherwise we're not going to be able to. All right, so we've seen that we can get our keys back. All right, and if we do that customer dict, and then we can also go down, we've got values. All right, so these are going to give us back our values. So remember, here's our dictionary. We had keys 1, 2, and 3, and we got values Alice, Bob, and Carl. All right. Another thing that you have, and this is somewhat interesting. So notice that key 1 corresponds to Alice. Key 2 corresponds to the value Bob. Key 3 corresponds to the value Carl. All right. So if I were to get my customers dict dot tab, we've got keys, right? We've got values, and another one that we use a lot is items. All right, so if I look at my items, this one's interesting. All right, so notice, remember we said 1 corresponds to Alice, 2 to Bob, 3 to Carl. Notice that it looks like it's giving me back, it's almost like this list-like structure, but it's a dict items type. And the first thing within that, it's like we got these parentheses, and then I've got 1 Alice, so the key value pair 2 Bob, 3 Carl. All right, so we can actually get back both the key and the value at the same time using items. All right, and this actually ends up being really, really helpful. I'm just going to show you, here's a use case for this. All right, so let's look at all of these use cases. First off, before we do that, let's actually see how we can grab an element from a dictionary if we know its key. So that's how you look up items in a dictionary. You actually have to use the key to look up an item. So if I've got customers dict and I put in a key of 1, it's going to return Alice. If I put in a key of 3, it's going to return Carl. All right, so you can use this square brace out beside, and that will get a particular item. Here's an issue with this particular type of access. What if you put in or request a key that doesn't exist? Right, so say key 4, right? That's not in our current dictionary here. If you do this, you're going to get an error, right? Because it's saying, hey, that key does not exist in that dictionary, right? And sometimes, there could be certain situations like maybe you're trying to do a mapping between 2 different dictionaries. You might not want to have, or you might, in certain cases, certain keys might or might not exist. This can be a problem, right? It's going to throw an error, and that's going to stop your program from running. All right. Here's how I would suggest you look up values in a dictionary. Instead of just using the brace and trying to put in a key, use .get. All right, so I'm going to open this left parenthesis, and then I'm going to do Shift Tab. So you pass in a key, and then notice it has this default. All right, and by default, it's set to none. So it has a parameter or an argument called default, and it's equal to none, which is saying, well, if you don't provide anything else, it's going to return none. All right, so now if I put in key 1, it's returning Alice. Key 3 returns Carl. But if I do key 4, it doesn't give me an error. What if I assign this to some temporary value? Let me assign that to underscore. And now let me do the type of underscore. That's that none type thing, right? So what it does, notice by default, if it's going to look up a key, if it finds that it returns its value, otherwise it's going to return the default value, which is none. So it'll allow your programs to keep running, and you can check to see if the thing that was returned is equal to none. All right. And if you want it to be something else, right, so you could specify your own default value. So default, maybe we want this to be, just copy it from there instead of trying to type it. You say, well, it's missing, right? It's a string, missing. So in this case, it's taking no keyword argument, so it just wants us to put that in there as the second argument. Okay, so this is a newer syntactic feature in Python. So it's saying, hey, we don't want you to put the keyword, just provide missing. All right, now if I look at the type of underscore, it's a string. Why? Because string is missing. Okay, it's our default value because it did not find that key. All right, so let's see if we can put all of this together in kind of an example. All right, let's look at a few different ways of doing this. So first off, let's assume that we have a list of, suspected customers, right? So we think or suspected customer IDs. All right, and let's say that's 1, 2, 3, and 4. And let's say that we want to iterate through our, our customers dict here and see if we find any one of these customers. We're going to print a statement saying that customer ID, whatever the current value is, their name is whatever the value of that dictionary is. Now, again, at this point, I am going to be using a little bit of flow control. I know we haven't really specifically gone through flow control just yet. But again, I think hopefully it's simple enough that you'll be able to follow along, even though you haven't seen the specific details of flow control. All right, so I'm just going to do a kernel restart, clear all outputs, just to get this from the top. And we'll run this down. All right. So what we're going to do, first thing, so remember we've got our customer dict. Remember, we have keys. Okay, so we could iterate over these keys and get those keys, and for each one of the keys, look up the value of that and then do that print statement. So what that would look like is something like this. So we could say, oops, let's do for current ID in our keys. All right. And then what we'll do is we could say customers dict, and let's do this brace structure, current ID. So this is going to be the customer name. Name is equal to that. And then we'll print, and I'm going to use an F string. I'm going to say customer, and I'm going to put that current ID in there. Okay. Is named that. And what we'll do is we'll put that customer name. So remember, I'm getting this ID. That's what this is doing. It's going to loop through each one of those keys, store the current key in a variable named current ID. Then I'm going to call that dictionary. I'm going to get the value that's associated with that current ID, store it in a variable customer name, and we're going to print that. All right, so we're going to have some problems, right? So this is going to give me an error. Why is it going to give me an error? Actually, I'm making one mistake here. What I need to be doing, I'm going to look at my suspected customer IDs instead of my keys. So again, this might be a case where we think we've got some customers that should be in there. And what we're going to do is we're going to iterate over those suspected ones, see if we can put them in there and get their name. All right. So it finds Alice, Bob, and Carl, right? But we notice it says, hey, when I got to this 4 here, I get a key error because that's not in there, right? Okay. Well, one way that we could get around this, right, is we could say, well, instead of just doing this brace access, we could do that .get for whatever that current ID is. All right. So remember, in cases where that customer name or when that current ID is defined in that dictionary, when we do a .get, it's going to return that value or the customer's name. And if it's not found, it's going to return none. So now when we run this, we can see that customer 4 is named none. Well, what if we don't want to print the case where it's none, right? We could very easily do something like, well, if customer name is not none, then we can print that. All right, so in this case, we've used a little bit of flow control. We've got these suspected customer IDs. We check our dictionary. If it's not found, it returns none. And then we're checking right here to say, is it not none? Okay. Another way that we could have done this is instead of looking at the suspected customer IDs, right, we could have just iterated straight through those keys. So I'm going to leave that right there. So that was really showing how we could use the get and we could check against is not none and keep our code running. Well, we could also just look at the actual dictionary, right? So we could, instead of saying suspected customer IDs, let's actually just go through the keys of the dictionary. That way we know that they're going to be in there, right? Because we're actually going to read the keys out. So the only way that a value would be returned for one of those keys is that it's actually in that dictionary. So we can use keys to iterate through that. That's going to allow us to eliminate this piece right here. I would still recommend that you use get. Okay. Now again, we haven't done proper flow control yet, so notice it's got this white space right here, and that's noting that, hey, these 2 lines are underneath this 4. In this previous example, when we had the for loop, that first customer name assignment got indented, saying that that's going to occur. We're going to run that line of code for each one of those iterations of that for loop. Then we had that if statement, and then the if statement, when we did this print, it's actually nested underneath this if clause. So it's only going to run if that is true. And again, we'll get to that proper flow control. Just showing you a little bit of these different cases. It's a little bit easier to do it with a for loop. So in this case, that's going to be just fine. All right. Now, the last case that I want to show you is, so this one we were using an external list and we had to use, some logic in here to make sure that we didn't get invalid values printed. All right. In this one, we're iterating over the keys. Then we have to use the keys to get the name, and then we print that. Now, remember, we have keys. All right. We have values. All right. And we have items. This is returning 2 things at a time. All right. Now I'm going to show you this because this is going to kind of pull back something we saw when we were talking about variables. We talked about multiple assignment. Well, you can actually use multiple assignment in this case because each one of these items, so here's your first item, it's that key value pair. Here's your second item, that key value pair. We can actually use multiple assignment to store these in that for structure, and then we can just print them out, and that's going to allow us to make the code even simpler. right? So I can just copy this down. And instead of iterating over for customer or current ID in the keys and then using this .get, I can do this all in one go. So I can change this to items. All right, I'm going to delete this line. All right, and let's comment out that print statement. Just put a pound sign, and let me just print current ID. So notice when I'm printing this, so I'm just saying for current ID in customer. So it's iterating over those items, storing it in current ID, and I'm just going to print whatever gets stored. Well, it's giving me back two things: 1 and Alice, 2 and Bob. So key value, key value. So it's actually giving me back current ID, customer name, current ID, customer name. It's giving me back those two things as essentially a tuple. That's what this object is called. Just the parentheses, so that is a tuple collection. So I can do this. So I can say, okay, well, you're giving me back two things at a time. Put the first one in current ID, the second one in customer name. And now when we run that print statement, we've simplified it even further. All right, so this is where we would use items. All right, we can get back those individual, pairs, or it can be more than two, or it's going to give us back two things. But what I'm about to show you is it's not always the case that a dictionary is just as simple as a key and a single value, but it'll give us back those pairs of keys and values, and we can work with them from there. All right, so let's look at one other case right here. So first off, what we've seen is something like this. Let's get our customers dict back down. I'm just going to go up here to where we defined it and make a copy. All right, so there's our customers dict. All right, keys and values, right? So key value. Now, the value of a dictionary can actually be another dictionary. It can actually be any object. It can be a list. It can be a function. It can be anything. All right, so we could have something like this. So what if I define a dictionary for each one? And remember, dictionaries are keys and values. And I'm going to make a name, and then I'll also make an age key. All right, so notice this is another dictionary right here. Okay, so I've got a key of 1. So here's the customer, and here's all their information. Maybe I'm keeping track of both their name and their age. Well, let's do this for all of them. So let's say we've got name keys. So Bob and Carl, and let's give them some ages. So let's say Bob is 40, and let's say Carl is 35. All right, so now if I run this, right, so now if I do my customer dict and get the keys, all right, so that's still good. Now if I get the values back, right, so the values are still, it looks kind of like a list at the end, right? We've got those square braces, but each one of the elements in there are dictionaries. All right, so now if I were to do something like this, say for customer info in customers dict dot items, and I print that customer info, right? It's giving me back that first element, that's the key, and then here's the value. Okay, key value, key value. So you can do nested structures, right? So just to give you an example, right? What if we wanted to get the name and the age? Well, the key thing to note is when we're running through this, so now I know that first thing is the customer info, and then it gives, or the customer's ID, and then everything else is their information. So maybe we can revise this since it's returning two things at a time. Maybe I do customer ID. That's going to be the first thing. So that's going to get assigned the 1, the 2, the 3. Right, so now let me just do a print, and let's just make this. All right, so it's printing out both of those things. All right, so for each one of our customers, maybe I could say create a new variable of name, and I could say customer info, right, because that's what I've stored the value as, and I know this gets tricky, this takes some practice, you've got to work with this to kind of understand this. So it's returning ID and customer info, and as we see here, this whole customer info thing is just a dictionary, so it has keys and values. So I want to get the name key, so I can say, well, get the name key from that, and then we can get the age, which is going to be customer info, whatever's stored in that age key. All right, and now we can come up with a better print statement. So we can say something like, we'll print, let's say customer name, and I'm going to put in parentheses there their ID, just using F strings. I'm just popping in variables. So there's the name, there's the customer ID, which gets set there, putting that in parentheses, and I'll say is age years old. All right, so customer Alice, who is customer ID 1, and so I got to change. Notice my problem, I'm printing their name again because I'm getting the wrong key right here. I need to get the age key. So let me change that to the age key. Yeah, they're 25 years old, 40 years old, 35 years old. So it's a very flexible data structure that you can use. And again, the key thing is you kind of start doing this mental mapping between keys and values. And again, it can be nested. And one thing, you know, in future videos, I'm going to be looking at working with data on the web. And the web uses a format, or at least it's very prevalent on the web, a format called JSON for data, or JSON for data. And JSON is, you know, has a lot of nested dictionary list type of structures once you read them into Python. So getting a good grasp of this is pretty important, especially if you're ever going to work with web data. All right, so the final thing that I want to show you regarding dictionaries, this should be relatively quick, is how you can add items to them. All right, so if I've got, you know, a temp dictionary, and I could put in, let's just put in some simple stuff like key A. I'm just going to show you a few different ways of doing this. All right, so right now I've got this temporary dictionary. Okay, 1 is the key and it has a value of A. What if we want to add a new key to it? Well, there's a few different ways you can do that. So what if I wanted to add a key 2 that was equal to B? You could say 2 equals B. After you've already got the dictionary defined, so that's kind of a key thing. We've already defined the dictionary here, and we're saying, hey, create a new key 2 and make that equal to B. All right, so now when we look at our dictionary, we have 2 key value pairs. You can also do a dot update, and you could provide the new key value pair as a dictionary. So I could say, well, maybe we're going to do 3C. Notice that that's like just a little dictionary right there, and I'm calling update on an existing dictionary. That runs in place, and now we've got 3C. All right. In recent versions of Python, they've added a new way of updating dictionaries. So let's say that we have temp dict. We can use this pipe character, and let's make another dictionary over here. And let's do 4D. All right, now notice that this is printing out what we've seen before. So we've been adding elements. So we saw how to add it by assigning a new key and giving that a value, by providing in another dictionary and doing update. And that dictionary you provide needs to be in the same structure. So we just have key value pairs. And then here we're doing the same thing. We're using this pipe. But notice when we run temp dict this time, it didn't change the dictionary. So when we did this call, this method, it just updated the dictionary. So we had that new element 2. When we called this method, we had that new element 3. When we run this pipe, it actually doesn't, it shows us right here, it's returning and showing us what that update would look like, but it actually doesn't perform the update. So if we wanted to, we could do something like this. We'd have to reassign the variable. So temp dict, we're going to overwrite that with our temp dict updated to include this new key 4 and value D. All right. Another shorthand that was recently introduced for this is instead of doing this reassignment, because we've got temp dict twice, right? So that's a little bit verbose. What we can do now, let's say we want to add a key 5 and assign that to E. So we've got 5 and E. Now again, if I were to run this, right, it looks like it's there, but when I do temp dict, it's not there. So what we can do, that pipe, you can actually do a pipe equals. All right, so this will say not only do the update, but actually store that in the original object. So when we run that, now we've got that entry there. All right, so any one of these ways works. Personally, even though this is new syntax and this is this looks pretty short, and I personally, if I'm going to do dictionary updates, I like this method, right? Because I think it's very explicit, right? So I'm saying that there was a dictionary and then I'm explicitly calling a dot update. So to me, personally, the way that my mind works, this is a little bit more clear to a reader, and in particular, future me, when 6 months down the road, I'm having to look at my own code and try to figure out what was going on. This just tends to be a much easier format for me to say, oh, I get this, than looking and going, okay, well, what did that do again? So that's my preference. But again, they're all equivalent. You just need to make sure that when you're doing that pipe, that you're actually, if you're wanting to assign to it, you can use that pipe equal, or you actually overwrite that object. All right, so that is going to conclude our discussion of dictionaries. And again, we'll get a lot more practice with these in later videos as we start working with external libraries and web data.